This is a quick rundown of my blinking LED with Morse code program for ECE492 slash ME492. Uh, Basically, here's my code, and I wanted to go a little bit more in depth on this than was necessarily required. I could have just hard coded my name in there and been done with it, but actually added some functionality to be able to input any text string that you want and have it blink that out in Morse code. So from right here, you see I'm importing the GPIO modules necessary and time, and then getopt and system. Those allow me to pass arguments to the program, which I'll explain down here. And that allows me to send any text string I want. Here's some code that I borrowed from this source right here. This is basically a dictionary defined to say all the alphanumeric characters available in Morse code. You have A through Z and 0 through 9, and the associated dits and das that go with those values in the International Morse code standard. And then down here I added this one that makes space into 3 spaces, which I will explain in one of these other definitions down here. It allows the LED to blink an appropriate amount of time. I specified global variables for the pin number. I'm using pin 27 on the Raspberry Pi, and then a time unit here as 0.2 seconds. I felt 0.5 seconds was a bit slow for blinking between every thing. And then this just explains the standard for units of time. A dit is 1 unit, that's a short character. A da is 3 units, that's one of these dashes up here. So alternate between those based on whatever the input is. Then an element gap happens between every dot or dash, and a small gap happens between characters. A medium gap happens between words. So I'm implementing a binary Morse code type of function here, where I basically take all of these characters and turn them into ones and zeros, which I will then pass to the blink method and just use those ones and zeros to turn the LED either on or off. So a dit is a short character that's just on for 1 time unit, and then off for a time unit to represent a space between symbols. And then there's a da, which is on for 3 time units and off for 1. And then if there's a space passed to this, that represents the end of a character. So you want 2 more off time units so that you end up with a 3-unit gap there. And you'll see this more clearly in the output whenever I run the program, which I could actually do that right now. Say I'm at the bottom there. Morse code .pi -I for input, and then just do let's do SOS, so that's an easily recognizable one. Oh, forgot my Python there. Not running IPython right now, so. And the reason it's compiling is because it's actually blinking the LED right now. So you'll see down here, dit dit dit, da da da, dit dit dit, and that's represented below, dit dit dit, 3 spaces after those dits, da da da, 3 spaces, and then dit dit dit, and then 3 more spaces. So that's how that works, and you can basically pass it any phrase you want to, and it'll do the same thing and blink the LED. So here's the function that's actually blinking that, and I explained that just passing those 1s and 0s to here. This is set up very similarly to the original blink LED program that we did, just to test out the output through GPIO. And here's my main definition. This block here could probably be made into another definition to clean it up a little bit further, but I just left it down here. This is the input. So I'm trying to get an input flag, and if it doesn't input, it just outputs this error thing, message, and system exits with an error code 2. And then if it gets an option of -H, that's generally help. So it'll tell you Morse code.py -I, and then whatever input text you want. If you give it -I or input text, then it's going to assign that argument to the input text variable, and then that's used down here for character in input text. Go through Morse code, find the associated dits and das in that code definition dictionary that I have up here, and add a space after every character. Then print that out just so you can see it in the terminal when you're running it, and do the binary definition up here to get the binary, print that out so you can see it, and then actually blink the LED by passing it the pin you want to send the output to, the binary string of 1s and 0s, and the time unit, which is defined up here. Just left that as a constant. So that's the program, and I'll have another clip following this showing the actual blinking of the LED with my name. So there's the associated Morse code and binary that'll be sent to the LED for that.